Hi, guys. Okay, so let's look at chapter 3, composition of substances and solutions. And this is from the OpenStax book called Chemistry. So in this video, we will cover formula mass, mole concept, and the empirical in the molecular formula. But in the next video, we will continue chapter 3, and we will continue with molarity, solution concentrations. So first of all, let's look at the learning check problems. And in this video and the next one also, we will only be looking at the learning check problems. And we're looking at 3.1. Okay, so here we are given acetaminophen, which is C8H9NO2. Okay, and this is a covalent compound, which is the active ingredient in several non-prescription medications, such as Tylenol. So the question is, what is the molecular mass in AMU? So what is the molecular mass in atomic mass units? That is the previously this was used. Okay, so what does this mean? Here, this means that there are 8 carbons, there are 9 hydrogens, there is 1 nitrogen in this molecule, and there are 2 oxygens. So remember that this 8 applies only to carbon, this 9 applies only to hydrogen. There is only 1, this applies, whatever this number, there's 1 we don't write, and then this 2 applies only to oxygen. Okay, next thing, you're going to look in the periodic table, and in the periodic table, you will see what is the mass number of carbon. So periodic table, in the periodic table, you will look at the mass numbers of individual elements: carbon, hydrogen, nitrogen, and oxygen. Okay, so just a minute. Okay, so we see that the weight of carbon given in the periodic table is 12.1. And you know, sometimes it's in these cases, it's okay to round up or to, you know, round down, or in other words, you don't round down. If it is 12.1, you can just take 12 grams and that's fine. Hydrogen is 1.0008, so you can just write 1 gram for hydrogen, and that's fine. Then you have nitrogen, which is 14.01, and it's okay to use just 14 grams. And then you have oxygen, which is 16 point, or it's also said 15.99, but 16 grams. Okay, so what do you have here? When you do this, you do 8 times 12, 9 times 1, 14 times 1, and 2 times 16. So this is 32, this is 14, this is 9, and then 12 8s are 72. So you add all of this up. When you add, what do you get? Okay, so 12.8. So 12 times 8 is 96, not 72. So that was my error. Sorry about that. Anyways, so you are getting 96 grams from carbon, 9 grams you are getting from hydrogen. In this molecule, 14 grams is coming from nitrogen, and 32 grams is coming from oxygen. So when you add the whole thing, it comes out to be 151. Now, since I had not included the decimals, so that's the only figure I get. But had I included the decimals, my answer would have been a little bit more exact. It would have been 151.16 atomic mass units. Okay, so either way, you know, this is the way you calculate the mass numbers of, you know, or the molecular mass, or the molecular weight, you know, of the substances. Okay. All right. So that was 3.1. Now look at, so this is actually, it is called a molecular mass because this is a covalent compound. Covalent compounds formed by the sharing of electrons. So another thing is, anytime you have carbon, hydrogen, oxygen, and nitrogen mixed, you know, so this is like a covalent, you know, bonding. Now let's look at the formula mass. Now, formula mass and the molecular mass, more or less the same thing. The difference is that the molecular mass we use for the covalent compounds, but if the compound is ionic, then we use the let me write this down, formula mass. Formula mass. And again, that also is an AMU, but that applies to ionic compounds. So ionic compounds. And these ionic compounds are made up of metals and non-metals. So, for example, here, this is your problem 3.2, learning check. And this is on page 134. Page 134. And the initial one was on page 133. 133. Page 133. 133. And this is 134. Page 134. Okay, so here you are given this molecule which is called calcium phosphate. So calcium Ca3 brackets PO4 and brackets called whole twice. So this is an ionic compound because it's made up of the metal and the non-metal or the polyatomic ion. Okay, so that's why we use the term formula mass for that. Okay, now we are looking at calcium phosphate. It's an ionic compound, and here what is the formula mass of calcium phosphate? So here we are looking at three atoms of calcium. 3 atoms of calcium. So remember that this 3 applies only to calcium. This 2 applies to phosphorus, and this 2 applies to oxygen. Okay, so here we have 3 calciums, we have 2 phosphorus, and we have 4 2s are 8. 4 times 2 is equal to 8 oxygens. Okay, now same thing, look in the periodic table and get the mass number of calcium. So here we see calcium is 40.08. So 40.08 grams is coming from calcium. And next is phosphorus. Phosphorus is 30.97. So 30.97 grams coming from phosphorus. Oxygen is 16.00 or 15.99. So it's the same thing. Okay, so this is the grams coming from oxygen. So let's finish the calculations here. Okay, so we see that when 40.08 is multiplied by 3, we get 120.24 grams, and that is coming from calcium. When 30.97, which is the weight of one phosphorus atom, you multiply that by 2, then you get 61.94. That is the weight coming from phosphorus. Next is when you have 8 of oxygens times 16 grams. So each oxygen is 16 grams times 8, 128. When you add all of this, you get 310.18. Now, just a simple thing, the significant figures, when you are adding, right? When you are adding, in that case, you only use the decimal points. So 2 places after the decimal. Okay, so that would be the significant figures. Okay, so next is the concept of moles. Okay, what is, and another thing, anytime you write down, always write down in what context. So calcium phosphate twice. All right, and this guy was of C8H9NO2. Always write down the units, and always, let me write this on top. Always, please note, number 1, always write the units and then the second thing is the units, and then the second thing is the what is it called, the symbols or the names or the formula, symbols or the formula of the compounds. Okay, whether it's it's an ionic or covalent. So symbols and or depending upon what the context is, formula. Okay, always. All right, let's look at the concept of moles. Now, moles concept is, because we are dealing with atoms on a very small scale, these atoms are reacting. And when we say we have some amount, in grams and those things, that's fine. But we want to know how many particles are there, whether they are atoms, whether they're molecules, what are they, how many are there? So that's the concept of moles. So where does this come from? So just like you have 1 dozen of something, okay, and that substance, one dozen substance, and that substance can be anything, that is equal to 12 grams. Oh, sorry, 12, the number 12. So 12 of that substance, okay, substance, or rather, let me just put this, 1 dozen particles, sorry about that. So 1 dozen particles, 1 dozen particles is equal to 12 particles, and these 12 particles is equal to whatever the weight of these particles is in grams, okay, gram particles. So whatever their weight is, okay. So the weight is going to obviously change. So for example, you have 1 dozen bananas, right? 1 dozen bananas means that we are talking about 12 bananas. BANANAS, okay. So 12 banana, and whatever the weight is there of these bananas, you put that, okay. So that's one thing. 1 dozen pencils, on the other hand, will have a different weight, but all of them, we are talking about 12 pencils, and whatever the weight of these pencils is, that is the grams of pencils. So weight is variable, right? The number of particles is the same, and the dozen is the same, okay? So now let's look at 1 dozen, for example, shoes. So 1 dozen shoes, or 1 dozen cars, okay? 1 dozen cars, totally different. Shoes, fine, 12 shoes, but the other thing is the 12 cars, okay? The weights are different. 12 cars are going to have a huge amount of weight, okay? Shoes, okay, depends, what the shoes are, but whatever their weight is in grams, so that weight. So if you look at this, that the cars and the shoes and the pencils and the bananas, all of them weigh differently. Their weights are changing. However, the thing that is stationary and stable and does not change is this quantity, dozen, and that relates to 12 or something. Okay, and then you can have anything here. Now the same concept applies to the moles. So 1 mole of something contains the Avogadro's number. So 1 mole particles, and those particles could be anything, and that anything can also include ions, can also atoms, can molecules. So anyways, 1 mole particle is 6.022 into 10 to the power 23 particles, okay? And whatever the weight of the particle is, that's the grams of the particles, okay? So this is the very simple equalities. Now let's apply it to other things. So here you have 1 mole of let's do bananas here. 1 mole bananas, NaNAS, we have 6.022 into 10 to the power 23 bananas. Now that's a lot of bananas, okay? And that is the weight of bananas, whatever their weight is, okay? So that's one piece. Next is 1 mole of pencils. This 1 mole of pencils similarly will be this Avogadro's number, pencils, and whatever it is, their weight is the same, okay? Grams of pencils. Okay, next is 1 mole of shoes. Same story. 1 mole of shoes, 6.02 to 10 to the power 23 shoes. And what is the weight of those shoes? You have weigh it and you will see it. So that is in grams of shoes. Okay, next is 1 mole of cars. Same story, 1 mole of cars, like a lot of cars. That's a lot of cars, a lot of work on the cars. So these cars, again, will have a very different weight. So that's why they prefer to use like larger units, like tons and like, you know, those things. Anyways, so that's one story. Now, let's move on to the applications of the moles in the atomic world. So 1 mole of an atom is equal to the Avogadro's number, 6.022 into 10 to the power 23 atoms. Okay, 1 mole of atom is the Avogadro's number of atoms, and whatever atom it is the weight of that atom in grams. So grams of atom, whatever the weight is, that many atoms. Okay, then 1 mole of molecule, same story, 1 mole of molecule, same number of particles. Instead, you put molecule here. Okay, and you have that is equal to whatever the grams of the molecule is. All right, like for example, like gold just by itself is atomic, but if you have like water is a molecule. So water is made up of H2O and gold is just Au. Okay, next is 1 mole of ions, same story. 1 mole of ions is 6.022 10 to the power 23 ions. So what was the need of having this very big number? The need is because we are dealing with very small particles. Atoms and molecules and ions are so small you don't see. So there has to be substantial amount that we can see, we can measure, we can weigh, and that weight, we should know how many particles it is connecting. Okay, those things. So it's again the grams of ions. Okay, so that's one piece. Now, based on these are the equalities. Okay, every equality will have a conversion factor. Every equality has a conversion factor. What is that conversion factor? That conversion factor is basically conversion factor. Okay, so this, and in this conversion factor, you are going to write down whatever entity is given to you, and this entity given has some units. Okay, and those units you want to convert, and you need to find another units. Okay, and you are given units, the given units here. Okay, and this is dividing, and this guy is multiplying. So these are the units, the given units are on the bottom and the upper one are the top. And so what happens is that these are the units that you want unit. Okay, so this piece is called the numerator. Numerator are like on the top, and this guy is the denominator. Denominator is at the bottom. Okay, now why do we put this the given? So here, this piece, this given units and the other given units, in other words, the ones that you're trying to convert from, so the ones that are in the equality, they cancel out. Okay, so and then, so this piece is coming from the equality. Okay, now let's look at some examples here. Okay, so here 3.3, this is, okay, so you are given here 3.3, 3.3, and this is on page 138. 138. Okay, here they are saying beryllium. You're given beryllium. Okay, beryllium is a light metal used to fabricate transparent X-rays windows for medical imaging instruments. How many moles of beryllium? How many moles of beryllium, okay? How many moles of beryllium are in a thin foil window weighing 3.24 grams? How many moles of beryllium in 3.24 grams? Okay, so in other words, we are given, you are given, the given is the grams of beryllium, and that is 3.24. And you need to find the moles of beryllium in 3.24 grams. Okay, so in other words, convert, that's the short word of saying convert the grams to moles. Okay, so here's something that you need to know, the equality here. What is the equality? The equality is you're going to see that the 1 mole of beryllium, 1 mole of beryllium. Now, what is 1 mole of beryllium? You look in the periodic, this information is in the periodic table. Okay, look in the periodic table and get the mass number of beryllium. So whatever you see in the periodic table is moles. Okay, periodic table. So let's note this here. Periodic table. In periodic table, the elements, these are all 1 mole, the information you see in the periodic table. So that is on 1 mole. And in that 1 mole, that mass number. So that mass number is in grams. So basically, in the periodic table, you see the molar mass of each element. Okay, molar mass of each element. Okay, here we see the molar mass of each element. What does that mean? We see that the elements are given, so molar mass, the units there is grams per mole. So 1 mole, so that's grams per mole, is this 1 mole per, that's a per mole, is how many grams? Okay, and yeah, all of them, you know, these guys, they all contain, let's put this here, they all contain 6.022 into 10 to the power 23 atoms. So this piece that you see about the information in the periodic table is that about 1 mole of every element. Okay, so that's the molar mass, which contains 6.02 to 10 to the power 23 atoms of that element, and that's the grams per mole. So anyways, so here we have given the beryllium, which is 3.24. Now, from the periodic table, we see that 1 mole of beryllium, the weight of that is, beryllium is 9. This is 9.012 grams. Okay, so this information is coming from the periodic table, and that information is basically on 1 mole. So 1 mole of beryllium, so we know that 1 mole of beryllium is equal to 9.012 grams. So the two conversion factors are 9 0.012 grams over 1 mole, okay, of beryllium. Okay, or 1 mole of beryllium over 9.012 grams of beryllium. So two conversion factors from the same equality. Okay, so which one are we going to use? So write down your given. First of all, we are given 3 point, what was that, 3.24, given beryllium 3.24 grams of beryllium, 3.24 grams of beryllium, okay, times, okay, moles, 1 mole of beryllium, 1 mole of beryllium over, because we convert grams, because this is what we want. Remember, the unit that you want is going to be on the top. The one that is given in the equality, you have to cancel out, you know, or remove. So that stays in the denominator. So we want to get rid of the gram. So this is 9.012 grams of beryllium. So that's basically the molar mass, just flipped. Okay, so what we see here is the grams of beryllium and the grams of beryllium cancel out, and you're just left with the unit of the moles of beryllium. So next thing is 3.24 times 1, divide that by 9.012. Okay, so that's all you do. Next is, let's just finish this calculation. Okay, so when we do this, we get this number 0.35952. So looking at the significant figures, so we see that the significant figures, this is 3 significant figures, and this one is 4 significant figures, and you should have, this is only 1 significant figure. So 1 significant figure is just an exact number. You can ignore that. So now you have 3.24 times 1, divide that by 9.012. Okay, and this gives you 0.359. So because this is multiplication, so there should only be 3 significant figures in the answer. Okay, in the answer. So we need to keep this, we need to keep this, we need to keep this. So we are going to drop 5. Okay, but 5 is, because it's 5 is there. So what happens to 9? 9 get rounded up to 10. And now our answer becomes 0.360 moles of beryllium. Okay, so that's the conversion from grams to moles. And similarly, you can convert moles to grams and so forth. So now let's look at the next one, 3.4. Learning check 3.4. 3.4, and that is 3.4, and that is on page 138. 138. Okay, here. Deriving grams from moles for an element. So you are given moles and you need to find the grams. So this is a moles to gram conversion. And so what is given here? What is the mass of 2.561 moles of gold? So you are given 2.561 moles of gold. Okay, moles of gold AU. Okay, and the question is, how many moles of gold is this? How many moles of gold? Okay, so 2.561 moles. So here, anytime you do grams to moles or moles to grams, you will need, so for conversion from moles to grams, you would need the mass number or mass number of gold and that is also called a molar mass of gold. Molar mass of gold. Okay, and that's going to give you the grams. Okay, so this is our map. So let's do this from the periodic table. Again, look for the mass of gold. So the mass of gold is 197.0. So the mass of gold, or the mass number of gold, is equal to, and this is also called a molar mass of gold. So don't forget that, 197.0 grams. So that is also called a molar mass of 1 mole of gold. Molar mass of gold is 197.0. Okay, now, so write down what is given to you. You are given let's do it here. I don't have the space. 2.561 moles of gold. And we need to find the grams of gold. So we know that 197.0 grams of gold is equal to 1 mole of gold. Okay, so this piece is the molar mass of gold. Okay, so here you are taking the gold, the information on the gold, 197.3. Actually, that is grams per mole. 1 mole. So that's what you have here. Anyways, now you cancel out the moles of gold and the moles of gold. And now you're left with 2.561 times. So 2.561 times 197. So let's see what you get. Okay, so when you finish the multiplication, you have 504.51 grams of gold. Okay, so that's the conversion from moles to grams. So in both the cases, grams to mole, moles to gram, you take the molar mass. Okay, next is 3.5. Okay, 3.5, and 3.5 is on page 139. Page 139. Okay, a prospector panning for gold in a river collects 15 grams of pure gold. So here you have 15.00 grams of pure gold. Okay, how many gold atoms? So now we are looking at the atoms. So number of atoms. Okay, how many gold atoms are in this quantity of gold? So find the number of atoms. So anytime you have this number, that means there is somewhere we are talking about Avogadro's number. And what is Avogadro's number? Avogadro's number is of 1 mole, 6.022 into 10 to the power 23 atoms. Okay, and because we are looking at atoms of gold, and this is present in 1 mole of gold. And 1 mole of gold, the weight of 1 mole of gold is, I'm just for the sake of doing it, is 197.0. 197.0 grams of gold contain 6.022 10 to the power 23 atoms of gold. Okay, so now that means now we need to find how many atoms are there in 15.00 grams. So write down here 15.00 grams of gold. Okay, 15.00 grams of gold, multiply by, you know, one way would be, let's convert it to grams to moles. And you can also do direct, but let's convert it to moles. So because we want the moles, we're trying to find how many moles. So you get that on the top, write it in the numerator, 1 mole gold. 1 mole gold is 197.0 grams of gold. Okay, so the first step is converting grams to moles. Next is converting 1 mole, sorry. Okay, 1 mole of gold. 1 mole of gold contains 6.022 into 10 to the power 23 atoms of gold. Okay, so we talked about, let me just put this here. The first step is convert grams to moles using the molar mass. Okay, next is convert, when you get the moles, convert the moles to number of atoms. So moles to number of atoms. All right, so now we see that grams of gold and grams of gold cancel out. Moles of gold and moles of gold cancel out. We only need the atoms, number of atoms. So now just do the math, which is 15.00 times 1 times 6.022 into 10 to the power 23. Okay, divide that by 197.0 times 1. Okay, now since we are multiplying, we are going to look at the lowest significant figure. So these are 4 significant figures. These are 4 significant figures. 2, 3, 4. These are also 4 significant figures. Okay, so let's see. What do we get here? Okay, so when we do the math here, 15 times 6.022 divided by 197, and then you move the decimals around and you get 4.586 into 10 to the power 22 gold atoms. Okay, so that is the answer. So write the units, and so 4.586 times 10 to the power 22. Okay, next is 3.6. 3.6 is how many moles of sucrose are in 25-gram sample of sucrose. So this is on page 140. Page 140. All right, so right now we are given the how many moles of sucrose, C12H22O11, C12H22O11. Okay, are in 25-gram sample. So this is 25 grams sample. Okay, so how many moles? Find the number of moles. Okay, so what would we need here? So since this is a grams to moles conversion, and so for grams to moles conversion, you would need the molar mass. Okay, and so we would need to have the molar mass of C12H22O11. So let's do this. So we see that there are 12 carbons, 12 times 12 carbons. Then we are, just one second, sorry. Carbon, hydrogen, and oxygen. So carbon is 12. So 12 carbons, hydrogens are 22, and oxygen is 11. Times. Okay, carbon 12. So the weight from the periodic table is 12. 22, the weight from the hydrogen is 22. That is 1. So that's 1 carbon, 12 grams. One hydrogen is 1 gram, and oxygen is 16 grams. 1 oxygen is 16 grams. So that's each. Okay, so this piece is carbon, hydrogen and oxygen. Okay, so what do you get here? So 12 carbons times 12. So let's just finish this. So we see that 144 plus 22 plus 176. So that comes out to be 342 grams per mole of C12H22O11. Okay. Now the question is in 25 gram sample, 25 grams sample of C12H22O11 times. Okay, so we need to find the moles, right? 1 mole of C12H22O11. Okay, over 342 grams of C12H22O11. Okay, so we have now, sorry about that. Okay, so we have 25 times 1 divided by 342, and you get 0. This is equal to 0.0730. Okay, so that when you do this, the grams and the grams cancel out, and you're only left with the moles. Okay, so this is these many moles of C12H22O11. Okay, so that is the 3.6. Okay, then is the 3.7. Okay, next is 3.7. Okay, our next problem is 3.7, and this is on page 340. Oh, no, sorry, it's 141. 141. Okay, so what is the mass of mass? Here they're asking you to find a mass in grams of 0.443 moles of N2H4. N2H4. Okay, so you are given the moles. No, you're given the moles and you're trying to find the mass. So basically this is again moles to mass conversion. And anytime that happens, still you would need the mass number or the empirical like mass. Okay, now here we have the mass number, or sorry, the what was I called, the molar mass. Molar mass. Okay, so N2H4, let's get the molar mass first. Always N2H4 means 2 atoms of nitrogen and 4 of hydrogen, times hydrogen is only 1, nitrogen is 14. So here you have 28 grams coming from nitrogen, and you have 4 grams coming from hydrogen. So when you add the two, this becomes 32 grams per mole of N2H4. Okay, now you are given the moles 0.443 moles of N2H4. Okay, times the molar mass. So we know 1 mole of N2H4 in the denominator, and in the numerator is 0. Oh, wait a minute. What am I? A mass, right? You have to get the mass. So mass is 32. Sorry about that. 32 grams of N2H4. H4. So 32, now let's do the math. Okay, so when you do this, you see that the moles of N2H4 and the moles of H2H4 cancel out, and you're only left with 32 grams of N2H4. So all you need to do next is 0.443 times 32 over 1. So this gives you 14.176. So remember, 3 places after the decimal. Generally, your book is condensing and making it just 1 place after the decimal. That's fine too. Sorry, no, wait 1 second. It's a multiplication. It's a multiplication. So 3 significant figures here. So we need this, but we need to drop 7, and 7 is more than 5. Therefore, the remaining 1 plus 1 more electron, and that becomes, sorry, oh, so what am I talking? Sorry about that. 1 becomes 2. Yeah, 7 is dropped, then the 14, not electron, 14.2 grams of N2H4. Okay, this is okay. So now we are looking at the next learning check, which is 3.8, page 142. You are given C4H10, C4H10. Okay. In this compound, how many C4H10 molecules are contained in 9 point, so this is given 9.213 grams of the compound. So the question is, how many molecules are there? So number of molecules. Number of molecules are there in 9.213 grams. So that's something you need to find. Next is how many hydrogen atoms are there and the number of hydrogen atoms. Okay, in this, how many? Okay, so we will, first thing is when we have something like this, we are taking grams. So this is, so grams, convert the grams to moles, and then moles to the number of particles. Okay, so in this case, molecules, number of molecules. Okay, number of molecules first, we'll do that. Okay, so for that, we would need the molar mass of C4H10. Okay, so we see that there are 4 carbons, and each is 12 grams. There are 10 hydrogens, each is like approximately 1 gram. So you have 48 grams coming from carbon and 10 grams coming from hydrogen. So this is 58 grams per mole. All right, so molar mass. Now you take 9.213 grams, 9.213 grams of C4H10, C4H10. Okay, convert that to moles first of all. So we see that 1 mole of C4H10, and what's the weight? 58 grams of C4H10. H10. Okay, so let's do this first. Okay, so when you do that, you see that the grams of C4H10 and the grams of C4H10 cancel out, and you're only left with the moles of C4H10. So 9.213 times 1 divided by 58, and that answer is 0.158844. 1588844. Okay, so we see here that there are four significant figures, and so if we can keep 1, 2, 3, 4 and remove this, so we are okay. So we have 0.158 and 8. Okay, and so that's the number of moles of C4H10. Okay, next is we will take the next step, which is, so this one was grams to moles conversions. So this is important. Okay, and I think I'm going to just stop here because empirical formula calculations are also very time consuming. So those students who are waiting, who just need to get started, they should on grams to mole, moles to gram conversions and formula masses and so forth. Okay, so now we have the moles and we need to find the number of molecules. So keep this in mind. Anytime you have number of molecules, that means that we are somewhere in that equation that relates to the Avogadro's number. And Avogadro's number is 6.022 into 10 to the power 23 particles. So in this case, molecules. Okay, so we are now looking at that 1 mole of any substance contains 6.022 into 10 to the power 23, so here we are looking at the molecules. So this is also going to be molecules. Okay, so the number of molecules we need to find, and so we'll take these moles 0.1588 moles of C4H10, okay, times, okay, so we have 1 mole of C4H10 contains 6.022 into 10 to the power 23 molecules. Okay, so we see here that the moles and the moles of C4H10 cancel out. And what do you get here? You have next is 0.1588 times 6.022 into 10 to the power 23 molecules. So let's do the math. Okay. Okay, so we get this number and we need to move it into scientific notation. So if you move this here, this guy, this 23, this is 95, this 23 becomes 22. Yeah, this 23 minus 1. So this would be, the answer here is 9.5, that's the scientific notation, 9.562 into 10 to the power 23, 22, sorry, 22 molecules, 22 molecules of C4H10. Okay, so that's the answer 1. That's the answer 1. Okay, next question is how many hydrogen atoms are there? So next is, this is, let's do this. I have to put this here. So this one we found number of hydrogen atoms. So this is part A and this is part B. So we covered part A here, finding the number of molecules. Then part B is the how many hydrogen atoms in 9.562 into 10 to the power 23, so 22, sorry, 10 to the power 22 molecules. So this is a part, small part over the whole. So we are asking how many hydrogen atoms are there. Okay, so that problem. So we see that in this case, we see the 9 in one molecule. So one molecule of C4H10 contains 10 atoms of hydrogen. Okay, so 9.562 into 10 to the power 22 times 10 atoms of hydrogen, one molecule C4H10. Okay, so here these are the molecules we calculated of C4H10. Okay, so here you see molecules of C4H10 and the molecules of C4H10 cancel out, and you're just left with the atoms of hydrogen. And so all you need to do is multiply this. So this becomes 9, basically 9.562 into 10 to the power. So this 10, so this becomes 23 atoms of hydrogen present in, you know, in the initial one was what? 9.213 grams. Okay, and so that is the answer. Okay, so, you know, I'm just realizing this video might become too long, so I have to hold on to the empirical formulas. We are going to cover them next video. And so for now, I am going to stop here. All right, thank you for watching. Bye-bye.